Hey everybody, we have factoring today. This is actually the opposite of what we did yesterday. Yesterday we were multiplying polynomials. Today we are going to unmultiply polynomials, or factor in other words. So we have two different problem sets here. We have the first page, 1 through 8, and those are all kind of the same idea, so I'll do a couple from there. And then we have the back side, which is a different factoring strategy, and we'll do a couple from that side. So the first factor strategy that we talked about is to factor out a GCF, or a greatest common factor. So when we have a polynomial, we want to look at the terms to see if there's a number and a variable that goes into all three of the terms. So let's start with number 2 here. Okay, if I look at these two terms, and I want to see if I can undistribute something, the trick is to see if there's a common factor. So when you look at 45 and 54, you got to figure out what goes into both of them. So 45 is actually 9 times 5, and 54 is actually 9 times 6. So 9 actually goes into both of those. And if we factor out or undistribute a 9, we're going to have some stuff left over. So what we're going to do is we're going to undistribute a 9. We're going to pull out a 9 or divide a 9 out of each of these, which is why I now have the 9 up at the front. So the leftovers are going to go down here. So the 9's kind of going to come out here in the front. So from there, we got to figure out what's left over. So we just divide by the greatest common factor. What's 45a divided by 9? 5a. What's 54 divided by 9? It's 6. And that's my final answer. So there's not a lot of work to show on some of these, and that's okay. I would consider that kind of a one-step problem, or you do one step and you can't really show anything. You could write what the GCF is, but that's about it. So that's fine right there. Now to double check, we could multiply back through and see if we get the right answer, or the original. So 9 times 5a, that would be 45a, and 9 times 6 is 54. Okay. So going from here to here is multiplying, going this way. Going from here to here is unmultiplying, or undistributing, and we call that factoring. Okay, let's look at one with some powers here, or some variables. All right, number 6, for example. So notice that now we have 3 terms. That's important. And we also have 3 variables. So we first start out by finding out what the number part of the GCF is. So I got a 12, a 36, and a 21. We got to think what goes into all 3 of those numbers. Well, 12 goes into 12 and 36, but it doesn't go into 21. The factors of 21 are 7 and 3. 7 doesn't go into either of these, but I think 3 goes into both of them. So it looks like the greatest common factor for the number part is 3. Then we got to talk about the variables. Okay, now what we're going to do is we're going to pull out or divide out or undistribute some variables. And so we got to figure out how many we can take out. What we do is we look for the smallest power of n, which is this guy. Okay, so I'm only allowed to take out n, 1n, or n to the 1 power from each of these, because if I pull out any more than that, I'm not going to have enough n's to go around. Like for example, if like, factor out n to the 4th. Well, I can't do that because that would mean I'm pulling out 4 n's and there's only 2 here. That would mean I'm pulling out 4 n's and there's only 1 here. So when you're looking for your GCF, find the smallest power of the variable, and that's what you can take out. So the whole GCF is 3n. So what I'm going to do is I'm going to put a 3n on the outside of some parentheses, and then I got to figure out what's left. Now there's a couple ways to do that. And one of the ways is to just kind of divide. So when I factor out or undistribute a 3n, that's kind of like dividing it out of all 3 of these. So I'm going to put a 3n, divided by 3n for each of these, and whatever I get is going to go here in the parentheses. So 12 over 3 is 4, and then I have a n to the 4th divided by n to the 1, and according to the quotient property, I should subtract these exponents, and that'll give me n to the 3rd. Right here, I got 36 divided by 3. That's going to give me 12. and then n squared over n to the 1. Again, 2 minus 1 is 1, so that's n to the 1. Okay, here I have negative 21 over 3. That's going to give me negative 7, and then the n's cancel. They both are n to the 1, and so I don't need any. And so this is what's left over. So we just undistributed 3n. Normally we would take the 3n and multiply it by this, and multiply it by this, and multiply it by this. And if we did that, that would get us back to where we started. So 3n times 4n to the third is 12n to the fourth. 3 times 4 is 12, n to the 1 times n to the third is n to the fourth. Okay, 3n times 12n would be this guy, 36n squared, and 3n times negative 7 would be this guy, negative 21n. So we just did the reverse of distribution. We found out what they all had in common, and we factored it out to the front. And to figure out what's left, we can think about like dividing the 3n out or whatever. Okay, let's take a look at the next guy. Okay, so again, start with the GCF for the number part. So I got a 16, an 8, and a 4, negative 40, excuse me. 2 definitely goes into both of those. 4 goes into all of them as well. And 8 is probably, I think, the biggest thing that goes in there. So the greatest common factor is 8, that's the number part. And then the smallest power of r is r to the third. So I can take out 3 r's from each of these, but I can't take out any more than that, because then I would be taking out more r's than this one has. I want to take the same amount of r's out from all of them, so the most I can take out is 3 r's, r times r times r, which is r to the third. All right, so what we're going to do is we're going to think about undistributing an 8r squared to the third. So there's an 8r to the third in this, and there's an 8r to the third in this, and there's an 8r to the third in this. And when I like undistribute them or divide it out, or bring it out to the front, we're going to have some stuff left over. So again, this is not the only way to do it, but one way to think of it is just divide by that greatest common factor and see what's left over. So 16 over 8 is 2. R to the 6 over r to the 3 is r to the 3. 6 minus 3 is 3. So we're dividing the coefficients, the numbers in the front, and we're subtracting the exponents. Okay, 8 over 8 is 1. And then 4 minus 3 is 1, so we have r to the 1. Remember, this is the quotient property. These are actually, the exponents actually represent repeated multiplication. So this r to the fourth over r to the third is actually r times r times r times r over r times r times r. And when you start canceling some r's out, you're like, oh, it's 4 r's to start with. Cancel out 3 of them, there's 1 left. So of these 4 r's that are all multiplying each other, I can cancel 3 of them, there's going to be 1 left. So that goes back to the quotient property we talked about. All right, here we have negative 40 over 8, which is negative 5. R to the third over r to the third is just 1. All the r's cancel, and we don't need to write any r's anymore. Okay? All right, so that's how you pull out a greatest common factor. Okay, so you got the answers to the odds. You should definitely try those on your own. And we didn't do number 4, but that's okay. We got 3 good examples here, and you got more examples in your notes. So when you're doing this assignment and you're using this video, make sure that you're actually progressing, that you're not just dependent on the video, that you're not just writing down answers that you don't know where they came from. Your goal here is to become independent. You need to be able to be doing these on your own by the time you're done with this assignment. That might take some of you more practice and more time, but that's what you need to be doing if you want to do well in the next quiz. So we're going to kind of move on tomorrow, and we need to make sure that this skill is already kind of practiced and ready to go. Okay, now on the back, the thing that are a little bit different about these is these are all quadrinomials, which means that they have 4 terms. The other thing is that they don't all have a common factor. So if you look at, let's take a look at this one for example. I know 7 goes into that, and into that, and into that, but 7 doesn't go into that. And also P goes into that, and that, and that, but P doesn't go into this one. And if you look at 24, you can say, 4 goes into that one, and 4 goes into that one, but it doesn't go into that one. So we actually, in this case, we can't find a greatest common factor. There isn't one, other than 1. You could factor it at 1, but that's not very exciting. So what we do is we use a different method, and the method we're going to use here is called grouping. Okay? You may have noticed that some of these have common factors, even if all 4 of them don't. So the method here is to group the first 2 and find the greatest common factor, group the second 2 and find the greatest common factor, and then we'll go from there. All right? So if you look at just the first 2 terms and think about what goes in there, the number part is 7. 7 goes into both of those. And again, we want to pick the smallest power of the variable. So I got a p to the 3rd and p squared, which means I can factor out a p squared. And when I do that, I'm just looking at the first one, we've got to figure out what's left. So 49 divided by 7 is 7. P to the 3rd divided by p squared is p. So there's the first term. Negative 42 divided by 7 is negative 6. P squared divided by p squared is 1, so that's just minus 6 times 1. So that's what we get there. So we found the GCF of the first 2 terms, and we factored it out. Now we're going to do the GCF of the last 2 terms. And in this case, it looks like it's going to be a 4. So we're going to factor out a 4. We'll figure out what's left. So 28 divided by 4 is 7. Okay, that means I'm also going to have a p left over from this guy, so 7p. And then negative 24 divided by 4 is negative 6. And so that's the second piece factored. Okay, now, this doesn't happen for every quadrinomial, but it will happen for every quadrinomial on this assignment. Okay, so there's lots of strategies to factoring, and this is just one of many. Just so happens that if you do it right on this assignment, you should notice that you have a common factor there, which is a binomial. Okay, so we factor the first one, we factor the first 2, we factor the second 2, and then we basically have 2 big factors, one on the left here and one on the right, and they both have this piece in it. And so what we're going to do is we're going to actually factor that out. Okay, so just making it a little bit simpler for you. If I had, let's say 7x plus 4x, I would notice, oh, there's an x in both of those. So I can undistribute the x, and what's left is 7 plus 4. Right, so that just x is coming down here. So when we distribute the x, it's like almost like there's kind of 2 copies now, because x has to multiply 7 and x has to multiply 4, and that's why I get up here. So distributing, it almost looks like the number of x's increases, but really I'm just multiplying both of these by x. And going backwards, it looks like the number of x decreases, but really I'm just factoring out the x and putting it out in the front. Okay, so that's something that we could do there. Now we're going to do the same kind of idea here. And notice that this is like the first piece, like a 7x, and this is the second piece, almost like a 4x. And they both have this chunk on them. This is like the x piece, this whole thing in parentheses. So we're going to take out that whole chunk, and what's going to be left is the 7p squared and the 4. Okay, so this guy and this guy, we undistribute it, and it comes out into the front. Now it looks like one of them is disappearing, but really what's happening is we're undistributing. And remember, when we distribute an x, like here, it looks like there's now 2 of them, and we're doing this in reverse. We're undistributing an x, so it looks like we go from 2 down to 1. It's going to look like we go from 2 of these down to 1. And what's going to be left over is the 7p squared and the plus 4. So when I undistribute that common binomial means 2 pieces, that's in the front, and then what's left over is here and here. And that's called factoring by grouping. All right, let's do another couple here. Okay, let's look at number 12. So some people observed in class that sometimes it might make sense to rearrange the middle terms, and you can definitely do that and have it work out. I don't think you have to in this case. Let's go ahead and see what happens. So if I group it the way it is, the only thing I can take out is like a v squared, because 11 and 12 don't really have any common factors other than 1. So my greatest common factor here for the first set is v squared. And similarly, I can't really find a greatest common factor here, and so I'm going to call my greatest common factor a 1, because the only thing I can think of that go to an 11 and 12 is 1, and since this doesn't have any v's, there's nothing else I can do. So even though it looks kind of funky, this is actually still going to work out. Let's see what happens. So if I factor out a v squared from the first one, I'm still going to have an 11 there, and I have 3 v's, v to the third, v times z, and I'm going to like take out 2 of them. I'm going to have 1 left. And then here I have 2 v's, and I take out 2 of them. I'm going to have no v's left, but I'm still going to have that 12. So what I did was 11 v to the third divided by v squared is this. 12 v squared divided by v squared is 12. So when you undistribute a common factor, you can think of it like you're really moving it out to the front, but to figure out what's left in the parentheses, you can take these two terms and divide it, because when we factor it out, it's almost like dividing it out. All right, now over here, the GCF is 1, so if I factor out a 1, 11v divided by 1 is 11v, and 12 divided by 1 is 12, so nothing really changes. However, notice that now these two guys match, right? I have these matching binomials, which is what I wanted. So even though it's like, wait, shouldn't the 12 be with the 12 and the 11 should be with the 11? You can definitely do it that way if you want to. If you want to group these two together and these two together, that will work. And you can rearrange this if you want to, but you don't necessarily have to either. Okay, so now we're going to take this common factor and we're going to pull it out to the front, and that's going to give me 11v plus 12 out front. Remember, it's not like I'm losing 1. When I undistribute here, it just goes from 2 to 1 just as like a result of the reverse distributing here. So those come out front, and then what's left is these two guys, v squared and 1. All right, let's take a look at another one. Okay. Now, one thing to be aware of as you're doing these is the third term. Okay, if the third, so there's 1, 2, 3, 4. If the third term's negative, you're going to want to factor out a negative with the GCF, and I'll show you why in just a second. Let's go ahead and group these up. Okay, so the common factor here looks like it's going to be 5, and also p squared. So the number that goes into both, the biggest number that goes into both is 5. The smallest power of p that I see is 2, so that means I can take out 2 p's from this one and 2 p's from this one. And when I do that, what's going to be left is a 4p minus 9. Where did I come up with that number? Well, 20 divided by 5 is 4, and p to the third divided by p squared is p. Negative 45 divided by 5 is negative 9. P squared divided by p squared is just 1, so I don't need any p's in there anymore. All right, now looking at these ones, I noticed that 3 goes into both. I think maybe 9 goes into both, and I think that's the biggest thing. So if I were to factor out a 9, watch what happens. So the greatest common factor is 9, so negative 36 divided by 9 is negative 4. I still have a p there. And 81 divided by 9 is, is positive 9. So it looks like I have matching factors, only the signs are off. Like this, I'm supposed to have a positive 4p and a negative 9, and I don't. So the idea again is if this guy right here, the third term, has a negative in front of it, it's going to help you out a lot to factor out the negative. That will make this guy positive and this guy negative. Because negative 36 divided by negative 9 is positive 4, and 81 divided by negative 9 is negative 9. And now my binomials match. Let me rewrite that for you so it's a little bit more clear. So we're looking for, whoops, that was a negative. Dang it. I'm trying to make it all nice and I just ended up doing the same thing. All right, so these now match and I can factor them out. And when I do that, it looks like we go down to 1 factor, but really we're just undistributing it. Okay, and then what's left is, if you just cover those up, you can see what's left. 5p squared minus 9. Oops, 5b squared minus 9. Okay. Now, another thing to keep in mind is that like your answer key may have these binomials written in a different order. For example, 5p squared minus 9 times 4p minus 9, that may be the answer in the answer key. Well, actually, you only have the odds. But when you are doing the odds, if you get something that looks like the same exact factors, but the order is different, that's okay because of the commutative property of multiplication. Right? Since these are two things getting multiplied, switching their position with each other doesn't change the final answer. So keep in mind that your answer key is only going to have one version, and you may have them written in a different order, and that's okay too. All right, let's do one more here. So when we look at these two guys, I noticed that that's negative, so we'll keep that in mind. I think that 7 goes into 63 and 7 goes into 7. So 7 is going to come out, and then b squared. That's my lower power here. So 63 divided by 7 is 9. B to the third over b squared is b. Or in other words, you can think of, I have 3 b's and I'm taking out 2. I'm going to have 1 left. Okay, if I take out a 7 and a b squared, like I'm taking out everything. And if I divide out everything, like 7b squared divided by 7b squared is actually 1. And so sometimes that happens. If the common factor is one of your terms, when you undistribute, you're still going to have a 1 there. So just to check, 7b squared times 9b will be this guy. 7b squared times 1 will be this guy. So that works. Now this guy is negative, and so I'm going to want to factor out a negative greatest common factor. And it looks like, 11 and 99, the common factor is going to be 11. So when I factor out a negative 11, that's like negative 99 divided by negative 11. That's going to be a positive 9, the b. And then negative 11 divided by negative 11, again, is 1. Okay, so if you're factoring out everything, I'm factoring out a negative 11 from a negative 11, that's like negative 11 over negative 11, which is 1. All right, now notice now my binomials match. Okay, that's great. So out in the front, 9b plus 1. Remember, I'm undistributing this, or the actual math word is factoring, but it's kind of the reverse of distribution. And so those are going to come out front. And if I cover those up, I can see what's left. It's the 7b squared minus 11. So 7b squared minus 11. Okay, that would be my final answer. Keep in mind what also would be correct is 7b squared minus 11 times 9b plus 1. That would also be correct. Okay, so practice, practice, practice. This is an important skill. It's not, some people find it pretty easy to do, but if you don't, that's okay. That just means you need to practice a little bit more. It also helps to know your multiplication table as well. So if you're struggling to find factors, I would recommend practicing multiplication tables. You can just Google multiplication table practice, and you can find lots of little games and stuff to kind of help you out. But you definitely want to be able to do these types of problems on your own going forward. So we're going to have a quiz on Friday. There's going to be one of each of these on there. Make sure you're not just using these videos to get through the homework, but that you're actually using them to get better. And by the time you're done, you've actually learned something and you have this skill mastered. Thanks for watching.